Okay, let's take a look at the first 10 questions on your take-home test. Give you a few hints and pointers here on some of the ones that might be troubling for you. Number one should be fairly easy. They're asking us to take the derivative of this function, so we're going to use the chain rule. So just remember to follow the steps. The big picture is you're taking the derivative of some function to the second power. So you're going to need to leave the function alone, knock it down to the first power, and then here you're going to take the derivative of the inside, which is 3x squared. Fairly simple problem. I'll let you finish that one up. And on the second problem, we're taking the integral and evaluating it from 0 to 1 of e to the negative 4x. So I'm thinking the first thing you need to do is to do a u substitution. So we'll set u equal to negative 4x, and the derivative of that, of course, would be just negative 4 dx, and dx would be du divided by negative 4. So substituting that back in, you'll see that negative 1/4 can just become a constant, which we'll pull out in front, and then we have e to the u du. So remember, the integral of u is just a simple e to the u, so you get negative 1/4 e to the u, and we're going to evaluate it from 0 to 1, and we're going to substitute back in what u is equal to, negative 4x. Okay, so just do the arithmetic on that and you should be fine. Alright, on the third problem, they're giving us some information. They're telling us that y equals 2. There is a horizontal tangent. So just sketch that, and you'll see that down at negative 2, the meaning of this is that the graph will approach this, let's see, maybe something like this. Who really knows exactly what it looks like? But it approaches that, becomes an asymptote, right? So thinking back about the definition of a horizontal asymptote, horizontal asymptotes, the calculus definition, as it approaches infinity, it's going to equal that value. So keep that in mind when you're solving this problem. Okay, and let's take a look at number 4, see what that says. So we have this function 2x plus 3 and 3x plus 2, and they're asking us to find the derivative of this. So of course, this one we're just thinking about the quotient rule. So the top function, or the numerator, we'll call f, and the denominator we'll call g. And just recall that the quotient rule looks like this. So just take this and do the simplification. You may have to distribute out your numerator, do some simplification, but it's a fairly straightforward problem. Okay. Number 5, we're taking the integral again of sine of x, and we're taking it from 0 to pi over 4. pretty fairly straightforward question, assuming that you don't forget that it's negative cosine of x from 0 to pi over 4. Evaluating that, of course this is a non-calculator, so make sure you have those values memorized. And then the cosine of 0, and just remember that cosine is all about the x, right? So here, of course, that would be cosine of 0 is 1, so the answer is going to be something plus 1, and this would be the negative square root of 2 over 2. Alright, let's go to the question number 6. Alright, this becomes a really easy problem if you remember the shortcut that we talked about in pre-cal. The limit as x approaches infinity is a Bobo-Batu Betsy variety. So we're going to look at the largest exponents of the numerator and denominator, and that's going to determine which rule we figure. Bigger on bottom, the limit goes to 0. If the exponent is bigger on top, we're going to use this rule, and it would be undefined. And if the bottom exponent equals the top, then it's the ratio of the constants. So, looks like the largest exponent is to the third, and on the bottom it's 4x cubed. So the ratio of the constants would be what? Just 1 over 4.